I'm here today to talk about introducing Kotlin in an incremental way, especially moving from Java to Kotlin, step by step, little by little. Please feel free to have any questions. So along the way, just raise your hand. We'll have a microphone out there. So the talk should begin by explaining or by telling you why are we interested in moving from one thing to the other, right? So we could be talking all day long about how to do it technically, and that's interesting, but also interesting for us is to understand the whys behind it. I'm big on understanding why. I'm big on understanding why, so that communicates better the goal to the team and to us, and when understanding better, and when we have a problem with the team or with a migration, we can understand, we can remember our goal and say, yes, we're doing this for a reason. So as of lately, we're becoming more and more comfortable writing functional code in the JVM. So as of Java 8, you can do streams and hierarchical functions and something like this. And I love Java, and Java, is a great language. I've done Java for so many years already, and I like it. And it's also, it has a little bit of baggage, right? So you have to maintain backwards compatibility, which is extremely good for the enterprise. And writing functional programming in Java is nice, but writing it in Kotlin better, right? So and we're getting more and more comfortable in functional programming in Kotlin rather than in Java. It's possible in Java. So in Kotlin, we also have immutability by default. So if you don't make a mistake out there and put some extra character at the end, everything is going to be in general immutable, right? Unless you use var or use something like that. So the key feature of Kotlin that I'm interested for this presentation is interoperability with Java. So I've been talking to somebody before the presentation, and they said, and how's interoperability? It's a difficult keyword, difficult word, by the way. It's easier to do it than to say it. So how easy it is to interoperate Java and Kotlin, and this is very good both ways. So from Kotlin you can call Java easily, as from Clojure. I've done a little bit of Clojure in the past, and the interoperability is very good from Clojure to Java, and from Kotlin to Java. The key feature here is from Java to Kotlin, it is also very good, and very simple. You almost don't realize that you're doing Java to Kotlin. So what else? We have a good type inference. If you've done other languages, just as Haskell or Scala, the type inference might be more powerful and left it there. But for the working programmer, for you and me, this is very good. This is very good for everyday life and everyday programming. So we also have nullability check. So as same as with immutability. If you don't do anything out of the box, things are not nullable, as opposed to Java. So Java chose nullable by default, and Kotlin chose nullable by default. So that makes things easier. This is something in which I think they really hit the nail on the head. So you can create hits of success. So they make things easier for you, and unless you say otherwise, things are great. Right? So why stay away from the beaten path where it is good already, and so you have the possibility, yes, but why do it? So you talk to people about moving to Java and moving to Kotlin and how Java is good and Kotlin is better, and they say, yes, but remember, whatever comes before the but is usually an excuse, right? So I want to get thin, but I love chocolate, which is true, both of them. So yeah, it's just an excuse. So there is this idea that people are afraid of change to some degree, especially if you're a big company and you're making millions out of your program, and you're like, should I change? Well, no, I'm making money out of this, right? So this is good software. I'm gonna keep it as is. I'm not gonna touch it. So it also applies to individuals, right? So I'm comfortable in Java. Why should I move to Kotlin? You have to give me a very good reason to do it. Nullable or immutable, it's not good enough suggestion or reason for doing it. So, of course, a new language implies new responsibility, especially if you're changing paradigm. if you're going from object-oriented to functional programming, you have to make a click on your mind. So you always do things in one way in object-oriented, especially if you hold a lot of state. And when you try to apply the same patterns to functional programming, you're like, oh, how do I do this? You know, this used to work in Java. How is it now? And you have to make a click. And when you make a click in your mind, you can take those, you know, those patterns that you have in functional programming back to Java as well if you want. So fear of adding new bugs, because especially when you're dealing with legacy code, every modification that you make to the software can break things. So you're trying to be a little bit careful. So changing code is always risky, but if you do it slowly and steady and check along the way and write tests, so risk is diminished. So maybe you don't have a lot of time, which is a good reason. You're very busy churning out features and you don't have time to think and to reflect. So it's good for you, right? You should be making a lot of money by churning out features out there. Especially with not thinking, that is very good for you. And very good for you also. So maybe you say, yeah, this is a good idea, let's move it to Jira. Let's keep it there in the backlog forever. Let's put it, at the bottom of the backlog. And whenever someone new joins the team, you say, yes, we have the migration. How is it? That's very good. It's there. It's been there for years. So in all seriousness, maybe there's a chance that you can delay some of the business requirements, because as we're going to be talking a little bit later, this migration to Kotlin should provide business value. Not only, CV-driven development. I want to work with Kotlin, so I'm going to convince my company that Kotlin is good and functional programming is good, and I'm going to be, the rock star out there. But rather, this migration needs to be positive for the company. So this might be the only reason, which is not really an excuse, which is the code is not yet ready. For example, you might be in a situation, and that really depends on your context, that you're working on an MVP, and you have a hard deadline. Okay, and you want to check something, and you want to see whether this makes sense or not. Right? You're trying to find the product market fit. So then maybe it does not really make sense to migrate, to invest more time in testing a feature, testing a hypothesis, and seeing how the market reacts to it. But just keep working in Java, validate or deny your hypothesis, and then we can talk about it later. The other reason for the code is not yet ready is because you have a lot of legacy code, and let's face it, everyone has legacy, right? And we love it, and we deal with the legacy code the best we can. But if it gets to a point, if you have too much of it, you don't know how to get out of it, maybe it's not the time to start this big pharaonic thing of moving languages, because that could add a lot more moving pieces out there and a lot more reasons for the software to fail, and that is not what we want. So let's start from experience. Problems that we find in migration. Sorry. So if we're moving in two different stacks, for example, from Ruby to Java, or from PHP to Java, we've done in the past, or from PHP to Kotlin, that we've done in the past as well. One of the problems is that you have no interoperability, or at least no easy way of communicating both systems. Right? So you can always do HTTP calls from one to the other, but things might be complicated or might be slow for your requirements. So in general, for that, what we do is we either do a big bang release and we code all of the features in the old system in the new one, and then we cross our fingers and pray if we are religious, or you do whatever you want, and you put it in production and boom, it explodes, and we said it was not a good idea. Or maybe it works out of the box, who knows? Or we have the two systems in parallel and we apply parallel change, right? A legacy code technique. The problem with the parallel change is there's this old system and this new system which is trying to catch up with the old one, right? And then a new feature comes, and what you do, you expand both, right? So you have a problem with the new system trying to catch up with the old one, and sometimes you can tell your business users to bugger off for a few days or for a few weeks. Sometimes you cannot. So another problem with that is if in your build system, meaning pipelines and scripts, you have two different stacks. So you might be very familiar with one, but not with the other. Let's say you're familiar with PHP and you know how PHP consumes memory, and you know what's the choking point for it, and how many resources you have to allocate, and how many. So a lot of that maintaining and you know the build system and the infrastructure. You know how it works for the old system, but not for the new one. So do you want to get experience playing with fire, or you know should we be a little bit more careful in playing in pre-production? So let's think about it, right? So there's even if we usually use Docker for our environment and deploying to the cloud, right? So there's a little bit of fine-tuning on how to install the runtime, how to do this and that, and which nitpicking we need to do to make it specifically how I want, etc. That I need to pay a price to understand and to learn how it works. So more fronts I will find, reasons for keeping it in the same stack, meaning in the JVM from Java to Kotlin, is we don't have this. We don't have to migrate all at once, because this is a secret of this keynote, of this talk. Given that we have very good interoperability, in the two systems, we can keep it in the JVM and migrate feature by feature or class by class from one to the other, whenever we have time, whenever it's the right time. So, what about the build system? Given that we're both using the tools and the libraries and the stack of the JVM, we can use the same build system, right? Whether using Maven or Gradle or something else, just add one more step to compile to Kotlin. Right? We want to see an example, and I'll leave the reference out there if you want to check it. So what about the infrastructure? Same reason. Given that we're still in the JVM, we know how the JVM works, we know which pitfalls it has, and we know how to tune it. Given that we are familiar already with Java, it is very easy to move to Kotlin. So this is the marketing piece, this is the motivation, this is the part in which I get you eager to move to Kotlin, and then let's see the more difficult parts. Because it's not un camino de rosas, right? It's not straightforward. So let's see real problems that we have in the migration. So there are important differences between the two languages. And so as I told you before, you need a click. You need to change your mindset. And changing mindset and habits is always, given that this is a people problem, so it's more difficult than technical problems, right? So some libraries and programs don't work as is, at least in our experience. So have you heard of JC Stress? JC Stress is a tool for checking concurrency and parallelism in the JVM. So you put code out there and say, I want my concurrent code to behave like this, and these are the expected outcomes, positive and negatives, and then you run hundreds and thousands of tests, and you get results, right? By doing the check rather than by trying to prove that the work in concurrent piece of code is correct. So I could not get it working. Working with Kotlin, I could not get it working. Maybe some people out there have experience working with this specific setup. It wasn't working. So, and some integration with libraries, which is a drawback and a pro at the same time, don't work that well as is. For example, Mockito, that we are very used in Java, has a better interface now, right? So we're using Mockito Kotlin, which is a DSL, which allows us to build Mockito instances like real Mockito, not copy of Mockito or inspired by Mockito, but real Mockito instances in Java, right? So we'll move it to Kotlin, and then when you try it, it's like, where have you been? I missed you a lot. So a problem that we find in a migration is once you try Mockito Kotlin, you're like, I should be doing this in Java, and you cannot, and you're like, oh, okay, that's yet another reason to move to Kotlin. So you might think that any project is a good candidate for moving from Java to Kotlin, right? Because after all of the hype, and Kotlin is a new language, and Kotlin seems to be better, which is true, or not, who knows, depends on your context. So is this project a good candidate? there is no obvious answer, yes or no. It depends on your context. But let me give you a few heuristics on whether to decide for one thing or the other. I mentioned you before that business should be aware that we're moving from one stack to the other, from one language to the other, right? And one way of justifying it to business people, to stakeholders, is having a return on investment. So what happens if I spend a lot of time and energy into creating something, migrating from one to the other, and at the end of the day, I end up exactly as I was before. So I've spent a lot of energy for what? No return. So I have zero return on investment, right? Meanwhile, if you come to a talk like this with Hadi, and you learn about Cater, and you get excited about Cater, and you say, oh, maybe we could try this, we could do a spike. You get a lot of value with solid investment. The ROI is very high, right? So we're aiming for this high return on investment on our choices. This is why for me at least, it is a good practice to have to convince business people, that these technology choices we're making is a good one. After all, we're partners, technical people and business people. We're working for the same goal. So we should be partners in taking these decisions. If you cannot convince your partner that this is a good choice, it's not so good after all. So return on investment is important. And another heuristic is, does this project have evolution over time? Because I had a friend working at the BSC, at the Barcelona Supercomputing Center, and he was working with Fortran code written 50 years ago. The last modification in the sinus and cosinus function was over 10 years ago. Okay? This code may not have tests, may not be good or ugly or nice, or I don't really care. The last modification was 10 years ago. This code has been proven correct by usage of 50 years in usage, right? So if it doesn't have churn, why should I invest in it? Let's keep it as is. Close your eyes, put this and I can look away and just say, yes, it's fine. So another reason for having churn in a piece of code that you want to migrate is migrating it needs constant love and constant care, right? So we're not going to be moving things slowly, steady, but we need to put effort into it. So why put effort into something that is dead? So more technical reasons. Is this piece of code, is this candidate following more or less solid principles or some good technical practice that you follow in your company? Because if it doesn't, we first have to deal with the mess that we're in, and then we can start the migration. So does it have a big legacy part related to the same thing, right? So what do we do when we have a legacy piece of code? First, you close your eyes, you wash your hands and say, this is good, this is fine, everything is fine here, yeah? And then what you're trying to do is try to stabilize the business value, right? By including some kind of test network of tests that allow you to modify things a little bit without breaking everything. So more heuristics. Are there isolated modules? Here that we can change a few modules and a few features in classes here and there. If we're lucky to have found isolated modules out there, we can hit the same API, change implementation, and no one is the wiser, right? Because after all, Kotlin and Java both, they compile to a jar, a fat jar usually, and then we deploy it to production, and everything is fine. So more heuristics on finding whether this is a good candidate or not. Let's assume you get out of this talk eager to try Cater and eager to move to Kotlin, and you're the only one in your team who's eager to do this. What kind of support will you find from your team? You'll tell this secondhand to them, and they say, "Yeah, that's good. That's good." So if you cannot find supporters in your team, it's going to be a very hard task to do it yourself, right? And I would not do it alone, because otherwise you're going to leave a piece of software in there that no one understands, no one cares about. You make the situation worse than it was before. So maybe finding a pragmatic approach of this piece of software in a hybrid mode, or just let's stick to Java, because Java is good after all. That's enough, right? But I'm not here to talk about the pragmatic solution of keeping it as is, but rather doing the big migration, because I wanted to give you a small recipe on doing the big migration from A to B and see how it goes. So let's start with the migration. So the first thing you do is you update your build configuration, right? Whether you're using Maven, you add these two plugins, and you exclude the default compile and the false details compile from the plugin, and create the source folders. So after this, there's a difference here. After this, you're now able to run Kotlin code with Java code along the way. So, okay, so I've updated the build configuration in Maven. Here you have the reference. You cannot see anything. Well, I cannot see anything from here, but this is so small. You have it for reference for if you want to try it at home. Okay, let me give you the same example for Gradle. You add the plugin, you apply it, and create directories. Support in Gradle for Kotlin in this aspect is better than in Maven, so it's easier to do. So this 3 lines of code, right? Very simple. Anyway, okay, so after you do this, you're now able, as I told you before, you're able to write and run Kotlin and Java code along the way. So I would suggest you deploy to production already to get early feedback, right? So there's nothing that has changed. You don't need to change the pipeline. You don't need to change this or that. The fine-tuning is okay. So why not get early feedback from users? As soon as someone complains that this is working differently than before, you say, okay, I've screwed it up. It should be working the same as before. I've modified something, maybe, I don't know. And you check, right? So you don't postpone the feedback from the user until the last moment, but rather try to do it as early as possible. So after you have updated the build configuration, you start a new task, and let's go slowly with a decision flow that we created. So you got a new task, okay? Is it a bug or is it a feature? Let's start with the bug. So what you do with the bug? So you get a bug from your product owners or from your QAs or from users, whatever, and we don't estimate bugs. Why? Because you don't know how much it's going to take to fix it. You don't know what's going to take to investigate and to reproduce and to fix it. So how can I estimate all of that complexity? We find it difficult. So if you get a bug, I would say don't migrate it yet. Let's postpone. Let's start with a simpler task, with a low-hanging fruit out there, and we can always go back to this later once this bug has been removed. Okay, and let's start with a new thing. Another reason for not migrating bugs straight away is when I have a bug, I usually want to get back to the green state in production as soon as possible. So I either roll back to the previous version or create a quick fix, test it, and deploy to production, right? If I'm learning Kotlin along the way, can you imagine me saying to my product owner, no, you know what? I need to learn these 2 or 3 articles. It's going to take me a day. And then maybe I can try to understand, to configure the build thing, and then I can take a look at the bug, and then in a week you'll have it fixed. Doesn't make sense, right? So I want the feedback the soonest that I can, and I want my users to be happy because they're paying my salary after all. So let's not migrate, okay? So another reason it's because it's risky. So especially if I don't have a lot of Kotlin knowledge or I'm just learning it, I could put together the risk of fixing the defects and the risk of my lack of knowledge in Kotlin, and then you put the 2 things together and it's even worse than before. So let's not go there. So one reason in which we might not have, the bug in production is because the feature is not well tested enough. So if it's not well tested, that could mean that migrating to Kotlin, we could introduce other defects, right? So there is also the uncertainty of how many files are we involved in fixing this. If it's a simple copy, right, that we need to change, it's usually more contained. But if it's a big defect in business logic, it could be here, and there. And no, No thanks. Thanks, but no thanks. And the last thing about the unknown is I want to reduce uncertainty as much as possible, right? I've said it multiple times. I'm not going to go over there again. So it's, okay, I have a new task, it's a feature. So where should I develop it? So I can start with already existing Java file, a new file, or an already existing Kotlin file. This is the, the three main possibilities that we find out there. So if it's already in a Kotlin file, I develop the feature in Kotlin, okay? And this feature might need a collaborator. So I say, for the time being, no, it doesn't need a collaborator. It's a leaf on the design of my object. So we're done. Why? Because we code the feature, and that's it. We try it, we test it. It's okay, perfect. We'll put it to production. So if it needs a collaborator, okay, we're back to the same question. So I have a new task. It's a feature, etc. So let's move here. It's not very visible, but it says new Kotlin file. So I need to develop the feature in a new Kotlin file. Okay. So what I do is I add a new Kotlin file with a new Kotlin test because we like to keep tests in production code always in hand, always in sync. It makes things easier for us developers. So you develop the feature in Kotlin and you move on, right? So you might say, yes, until now you're doing the easy part. You're explaining me how to code in Kotlin, which I knew already. And I said, yes, you're right. There's no migration. Now is when the recipe for the migration starts. We've covered the easy things in the beginning, and then let's go to the real deal. So you're now working with an existing Java file which has a feature and some tests, maybe. So let's ask, does it have tests? Yes. So this is a good point to stop for a minute. So if we have tests, they may or may not be good. I'm not judging, okay? But the thing is, you have now two pieces of software, production code and test, and they're having a dialogue, right? So test is asking a few questions to production code is answering, and then if you break one of the pieces, the test will be read, and then the dialogue breaks, and you have earlier feedback than going to production. Yeah? So what we can do is migrate the test to Kotlin. And we're not going to move the test to Kotlin, okay? We're going to make a copy of the file. We want to convert it to Kotlin, run both, because you can run, you can run the test in Java and you can run the test in Kotlin. And if things go well, both should be green. And then you can decide, okay, the migration from two others went well. I'm happy about the result. I haven't yet modified production code, but I'm learning along the way. Right? I'm learning along the way. So a way of doing this, which has nothing to do with Kotlin or the migration, in fact, is whenever you're trying to expand the knowledge in the team, you try to use pair programming. Right? We try to use pair programming as often as it is necessary, whether it is for production code or for complicated parts or for ops, for operations work, or for learning things. We try it because it is really effective, really useful. So whenever you have a teammate that knows a little bit more Kotlin than you do, so you say, come Jorge, can you please join me for a few, for the morning, and can we try this because I don't know, can you please help me, etc. It's quite effective. So the main thing to remember here is I want to first test my knowledge of Kotlin with something that is not really critical, okay? If I make a mistake in my tests and I break them, I still have Java tests. So if it doesn't have tests in Java, what we do is, again, we create tests in Kotlin. We're dealing with something which is not really dangerous yet, okay? Because we're not modifying production code. You run the test, you learn how it goes, you learn about the features of the language, you can get comfortable with it. If you want, use pair programming, or mob, or whatever you want, and expand the knowledge about it, okay? Let's play with safe parts so we can deal with critical parts later. So, if it doesn't have test, well, you have another problem, right? You have legacy code in there that you have just discovered. So, this recipe is about having the migration from one to the other. This is not about legacy code at all, but let's give a few tips, because why not? So how do we like to manage legacy code? So one way of dealing with it is they're described in Working Effectively with Legacy Code by Michael Feathers. So you have dependency breaking techniques in which you can extract the small part you need, right? Test it and migrate it, repeat another factor of migration, right? So you keep cycling as long as necessary, and then the legacy code becomes hollow. So you've tried to extract all of the dependencies and all of the difficult parts to test out there. You keep it in a good state, you put a safety net underneath, and then you can delete the legacy code, right? So that's one way of doing it. There are many others. So a small disclaimer. This is risky, and you need expertise, so and knowledge, so you have to evaluate if it's worth it. Not every piece of legacy code out there needs to be killed because we love each other very much, and legacy software is producing lots of money. So let's be a little bit careful of what we try to do. So no tests. You must realize we have an overhead of time, because for doing this small feature, we need to learn a little bit of coding. We need to write tests for the full feature, right? And then we have an overhead of time. So, well, we said in the beginning that we will be as pragmatic as we could. We will not waste a lot of time, okay? So I'm not playing fair, by the way, but it's okay. So by definition, legacy code, as following the definition of Michael Feathers, has no tests. So legacy code is code that has no test, okay? And testing something is usually a lot of time. Well, disclaimer, unless you are somewhat familiar with it, right? With a test or with a domain in which writing tests is a pain, but it's okay, right? So this is what we do for a living. The first time I went to the gym 10 years ago, and the last, by the way, the first time I went there, the 1 kilo dumbbell was really heavy, and now it's still really heavy, but it's get better along the way. So if we don't have a lot of tests, and this is an overhead of time, right? Should we ask ourselves, is this really a good candidate for migration? Can we find better candidates in my source code, right? Can we find better candidates that are more appropriate for the migration itself? Maybe we can keep this for later. Because after all, Rome was not built in a day. So why we start with the difficult parts while I'm learning. So how should I migrate? So after you created a test in Kotlin, or you migrated them to Kotlin, and you have Kotlin test code and Java production code, what you do is try to migrate production code. Slowly and steady, okay? Because we've learned a little bit along the way by migrating the tests. So our Kotlin knowledge is already better than it was before. But let's see how experienced I am in production code. So if I'm not very experienced yet, so what I will do is manual migration, right? So I start with a copy of the Java code. I put it in a Kotlin file with a KT extension, and I edit the Java and convert it to Kotlin manually. And then I test, and if everything is working, I'm done. So why manual migration? So by manual migration, we mean you run the test, and then you check that they're green, right? So you do TDD by refactoring, okay? And you start replacing the Java statements with the Kotlin statements. So for example, instead of having .stream, .filter, .collect, you do the native way in Kotlin, okay? So why the manual migration? So first and maybe foremost, you discover the weak points in your Kotlin knowledge, right? So you say, oh, I know how this works because I've seen a video of Hadi doing it, and he does it very well, and it's very simple in Kotlin. And then you go to your own PC and you're like, oh, this is not working. Well, I mean, let's watch the video again. Ah, yes, okay, fair enough. You go back and you're like, I don't have the knowledge yet. I'm not as proficient as Hadi is with Kotlin. Well, there's a reason behind it, right? But I'm not as proficient as I think I am. So, what can you do to get familiar with it? We suggest you get used to Kotlin one statement at a time. And whenever you have time, 10 statements, and whenever you're not, just one for the day. So, again, it is better to work doing pair programming, right? Because it helps with the growth as you as a person. Remember, the more you grow in the current project, in the current setup, the more you can take on future setup and projects and context, and the more you can teach, the more you can enjoy that together, right? So, why not? So now that I am pretty confident of my Kotlin knowledge, I would say, you know what, I know how this works. I've seen it in videos. I'm going to help Intellij help me. Okay? So what you do, you take Intellij to the rescue, you take a Java class, you copy it, create a new Kotlin class, which is called user.kt, you paste the code, and Intellij says, would you like to take it automatically from Java to Kotlin? I say, yes, please. Let's watch the video again. Boom, you're done. Okay? So Intellij is really helpful in this case. It really helps that the same company is producing Kotlin and the main tool, or one of the main tools to edit Kotlin. It really helps. The integration is straightforward, super nice. So I'm gonna have Intellij help me. But as you see, this is the second choice. So I'm trying to increase my knowledge in Kotlin by doing the manual migration myself. I want to discover the Kotlin features, and then once this becomes a chore, I'll let Intellij help me. In any case, after the Intellij conversion, I still need to check my code, because don't let anyone tell you otherwise. The automatic migration is not that perfect yet. So I need to check a few things. Okay, so what do I need to include in manual revision in Intellij code? Nullability. There are some things that can be improved, because once you know that your code is not nullable in Java, you can skip some of the checks. So you can say inline variable initialization, it can be better. Or me as a programmer, I can decide, I can simplify it. I can use companion objects, so I need to check that as well. Add throws in the annotation. So if you're using Lombok previously, Lombok and the manual conversion, the automatic conversion is not working so well yet, but let's give them a few more months. And then your inline function as well, you need to check all of that, right? Strings as well. Okay, so let's go back to a little bit to the basics of Kotlin, right? So you have the safe call operator, which is this, right? So you say question mark dot. This is only going to be called whenever it's not nullable. So if you know that the expression that we have here in our Java code produces non-nullable string, you can remove it. So the albis operator, same, right? So you're going to provide the default value here. If you know this, so B in this case, B is not nullable, you can delete, you can simplify. And finally, the normal assertion, again, it has to do with the original source code, with the original code in Java. In Java, remember, everything is nullable by default, right? So the automatic migration is being as careful as possible. You cannot infer all of the usages, so they say, oh, you know what? Let's keep it safe like this, and then the programmer can decide to optimize it. And this is what we're doing with the manual check. So let's go a little bit with the manual revisions one by one. So this is, can you read this from the back? Yeah. Okay. So this is the original Java code. We have a class foo, and the constructor here, we initialize it. It's mutable, like we like to do it in Java, because in Java immutable, very good. So you automatically convert it to Kotlin, and you have it here in the initializer block. Okay? And why you need this? You can put it straight away here. And even the IDE is telling you can do it all together while you do it separately. So you go Alt Enter and you move it there. So what else? What about the companion objects? So this is the way we do constant in Java, right? We can automatically convert it to this. But remember, constants in Kotlin don't need to live inside a companion object. It's not a must. So I can take them like this. Alright? What else? The throws annotation, which is the conversion of this throws IO exception, it is automatically converted like this. Okay? But in so many cases, I don't need it. Okay? The throws annotation is added automatically for maximum safety in the conversion, in the migration. The thing is, whenever it's not necessary, I can delete it. So let's see this video as well. This is Lombok. so first you de-Lombok, you turn Lombok code into Java code as well. There you go, it's long, okay? And then what you can do is the same game, the same procedure that we did before. So you take de-Lombok code, like plain Java, you move it to Kotlin, let Intellij help you, and then it gets automatically converted from one to the other. So more things that you have to check on your own. So you have this inline function, okay? So you automatically convert it, and then you can do it like this. Isn't it nicer? I mean, at least it's terser, that's for sure. We always complain about Java being very verbose, so this helps with the verbosity. So what about streams and collections? So in this case, when I convert it automatically, I don't know why, something is wrong here. Okay, and it's not working straight away. So what I can do is, you see, this is the thing that I was telling you about. So you do stream.filter and then collect, etc. Okay, so you convert it to the native way of doing it, which is stream.filter. So the migration is almost finished. You've taken your tests, you've taken your production code, you've gone slowly and steady. You're careful. You've applied legacy code techniques. You're really, almost there. The migration is almost completed. Right? So you either manually migrate or let Intellij help you and then check. And you run the tests. So two things can happen. First is tests are green and then you go home happy and work is done. But sometimes things are not working as you expect. So why tests might be failing, maybe you have the wrong abstraction in your code, right? So you're taking the wrong abstraction and the wrong metaphor in your code base, right? It's maybe because immutability in collections is working differently in Java and in Kotlin, and if you're actually modifying something in the Java, right, when it gets translated to Kotlin, things don't work as well, because you should not be doing that in Java. So, and maybe, and sometimes the more common reason is because you have highly coupled tests. So your test code and your production code is doing the same. You have the same, same assertions and then actions here. Same setup, then you have on the other hand here. So your test being very coupled doesn't really help with anything at all. After all, you're doing something in, something there, and it's same, right? So the thing is, if we can fix the test easily, okay, we go on, we move ahead, and we fix it, and we get to green, and we're happy again. If we don't, we're in a wrong state of the code. So we've started the migration, we've done a few things, we've invested some time in there, and for this particular feature that I'm translated from Kotlin to Java, how can I get out of the hole, right? So I've dug myself into a hole, and sometimes the only answer is to keep digging, and you're gonna get out of it. Sometimes the answer is you say, you know what, I did everything that I could, and this thing is not working, so I'm gonna check out. I'm gonna lose the half an hour or the 1 hour that I invested into it. I'm gonna try again. Why? Because there's usually a lack on your understanding, on your knowledge of Java or Kotlin or the migration or something that stops you from getting there, right? So sometimes it's very effective to take a break, lose all of your effort, and then start anew. So as we always say, each case is different and you need to decide for yourself, but throwing half an hour away is not really a problem, in my opinion. So one thing that I really like about this migration is most of the errors should appear in compile time. So if it compiles and you have a pretty good guarantee that the migration is complete, and you also have the test on top that check for correctness. So, and this is the thing I was telling you. So it's okay to abort from time to time. If you find yourself you're aborting every half an hour, maybe you have a bigger problem. But if you do it once in a while, it's okay. So now the test should go green. What you do, this is the full recipe. We've gone from the updating build configuration to having defects, which we're not migrate, and then migrate Java production and test code, and run the test, and etc. So this is the full recipe. You have it here for reference, right? So now what we can do is we slowly evolve the Kotlin code, right? So we always try to leave it better than we found it, following the Boy Scouts rule, right? And so we're trying to move from Java to Kotlin, and we're trying to leave the Kotlin tests better than we found it, the production code better than we found it. Okay. So the thing is, if we don't put a little bit of effort into our code base, we live in a shitty place. So who wants to live there? Well, not me. Right? So now that we have managed to migrate the inner pieces of our Kotlin, right? We can still call the Kotlin from other Java places, right? It's time to think whether we want to adapt the interfaces and start removing the nullability, right? Because Java is nullable by default and Kotlin is not, so you have to adapt your interfaces so they can be called as is from Java. And now that you've entered this thing, you can say, oh, maybe I can make the rest of my code base a little bit better and start swiping away the nullability and the mutability as well, if that is something that I am interested in. So finally, we have some recommended libraries. JetBrains and Javi cannot endorse them officially, right? But we've tried them and we like them, so we recommend it. They had good success for us. They might or might not for you. We like them. So for tests, you have Kotlin test and Mockito Kotlin, the thing that I was telling you about, which provides better DSLs. We really like it. Another note on it. If you're using Kotlin straight out of the box and you want to use, for example, Mockito, right? So things in Kotlin are a little bit special towards inheritance and mocking, right? So you need a few plugins out there to work with it exactly as with Java. So Spring, if you're using Spring, means open classes and methods, right? And by default, things are viral in Kotlin, so you need a few plugins to install to make it work, to adapt it to your flow. This is the reference for Maven Spring JPA, same for Gradle, and finally, disclaimer. This is our experience. We are eager to move some of our projects where it makes sense from Java to Kotlin, and what we say is use it under your own risk, right? We cannot provide advice for you for your own context because you are the one knowing your context and not me or not us. And not projects are equal. So what makes sense in your past project might not make sense now. Finally, this is something really important that I mentioned earlier. If you don't have consensus in your team from taking a big decision like this one, in your team, meaning business people as well, you're not going to get very far. That's all. If you have questions and comments, now's the time.
Any question?
No? Okay. You make my life easier. Thank you very much. No? Okay. You make my life easier. Thank you very much.